Hi guys. Let's start our introduction to LLD, that is low level design. So what is low level design? So low level design means a very in-depth view or a very in-depth understanding of how we are going to structure our code so that it will be very easy to maintain and very easy to read and very easy to extend the code. Okay, so uh, LLD means a set of guidelines or design patterns that we need to follow to make our code. First point is easy maintainability. The second feature is it should be properly extensibility. Okay, the third point is not it's required, but the main 2 points are this. Okay, so other thing can be readability. Okay, uh, third point is required, but the main point of the low level design is proper maintainability and proper extensibility. Okay, so what do you mean by maintainability? Okay, so let's see what we mean by maintainability. So what is maintainability? Okay, so what is maintainability? Okay, maintainability means uh, to keep our code in a working condition. Okay, to keep the existing features, okay, in a working condition, provided there is a no new features should be added. Okay, maintainability means keep the existing features in a working condition. Okay, keep the existing features in a working condition. Okay, and here one thing you need to note is no new features should be added. Okay, no new feature should be added. Okay, uh, so like what do we do in maintainability? So if the code is already in a working condition, so what can go wrong in this maintainability? So or what all activities do we perform in this maintainability? So one thing is we usually do bug fixes, okay, in the existing code, okay, to keep it in a working condition. Okay, what all things we do any third party dependency fix. Third, what can be a third option? The third can be a network change or interface change. So maintainability means keeping the existing features in a working condition in a code. Okay, so what do you mean by extensibility? So what do you mean by extensibility? Okay, so extensibility means like how easy will it be to add a new requirement in our code. Okay, how easy it will be to add a new requirement in our code. Okay, so low level design, okay, or low level design patterns enables us to achieve these two important points. Okay, there are other important points, but these two have the highest preferences. Okay, so like let us understand by one example like how the low level design helps. Okay, okay, I don't know if most of you have heard this or not. So previously phone pay, okay, phone pay to use its UPI was using Yes Bank, okay. So phone pay was initially using Yes Bank, okay, for its UPI transactions, okay. But you might have heard that Reserve Bank of India revoked the banking license of Yes Bank, okay. So what happens? So immediately phone pay switched to ICICI Bank, okay, for its UPI business, okay. So how did they do that, okay? And once this problem with Yes Bank occurred, so PhonePe was immediately within some hours able to switch its entire UPI platform to switch to ICICI Bank, okay. So how do you think it happened so quickly? How did PhonePe manage to so quickly switch from Yes Bank to ICICI Bank? That is because of proper low level design, okay. That is because of proper low level design, okay. And I guess they might have used something called a adaptive design pattern or a strategy design pattern, okay. So to do this immediate switch they might have used, okay, this, okay, and this also maybe, okay. So this is the benefit of properly designing the system and having a robust low level design. So as a part of a low level design, so let's see what is object oriented design pattern, okay, or OOPS, okay. So what is this OOPS, okay, object oriented design patterns, okay. So this is a way to structure code, okay. This is a way to structure or organize code, okay. So object oriented principles are basically a way to structure or organize the way we write our code, okay. So before the existence of object oriented principles there was something called procedural design patterns, okay. So before going into all those things, so let's see what happens in real life, okay. So let's see what happens in real life, okay. So in real life someone, okay, always does something, okay. Suppose someone does something, eat, study, run, take a break, like that, okay. So remember this point, like in real life someone does something, okay. So we can frame it like this: someone does something, okay. So now let's get back to what existed before object oriented principles, okay. There existed something called procedural language, okay. Okay, there's something existed called procedural language, okay. So in that procedural language, so an example of such language is C, okay. So in that language what happened is, suppose uh, okay, and this in this language, what procedure meant is a set of instructions. Okay, okay, and this procedure looked something like functions or method in today's modern languages. Okay, so something like this. Suppose if I do create a method called print student. Okay, and suppose I'll pass arguments as string, name, integer, age. Okay, and we'll simply print that here. Okay, print name, print age. Okay, so this print student, this procedure looked something like a method or a function in today's language. Okay, so instead of passing one arguments here, name, age, what we can do is in that kind of language, uh, there was something called a struct. Okay, okay, and this looks similar like class. So you define something called struct student. Okay, and you create uh, the data of student within it. Okay, the data can be string name. Okay, so, int age and so on. Okay, and uh, instead of passing these values here, what you can do, print student. Okay, then you can simply create student st. Okay, and print st dot name, print st dot age, and so on. Okay, however, there is some problem here. Okay, this is a very small example, that's why it is looking easy. Okay, but think the systems at a very large scale. Okay, consisting of millions of lines of code. Okay, the problem here is this procedures. Okay, these procedures, okay, can access. Okay, that is here which I mentioned here, these procedures can easily access the details of the student. Okay, and can easily modify it. Okay, this is a very small example, so it looks easy, but consider a very large scale system having multiple procedures. Okay, so there can be situations where one procedure will come and easily modify the details of the student. Other procedure will come and easily modify the details of the other student. Okay, or the same student. So in that case, this will be an issue. Okay, so uh, let's understand it by another example. Okay, so consider this as a master procedure. So this has the ability to modify each entities. Okay, okay, the entities don't have their own free will. Okay, in case of procedural oriented languages, consider a very large scale systems where there are multiple procedures, like they're dancing with different entities. Okay, they're trying to modify every entities. Okay, so there can be a difficult scenario, and here, as I said, okay, in real world someone acts on something. Okay, but in procedural oriented languages, okay, this rule is getting violated. Okay, here you see what is happening. Okay, here something, is trying to access someone and trying to modify it. Okay, so here something, that is this, is trying to access these entities and trying to modify it. Okay, so that's a that's I don't say it as a wrong concept, but in a large scale systems this can lead to problems. So what can be a proper way? As I said, in real life someone should modify something. Okay, not something should come and modify these individual entities. Okay, so what if this what if this someone try to modify something? Okay, okay, what if these entities have their own free will? Okay, what if these entities have their own free will? What if these entities have their own data and own functions, own behaviors? Okay, own something. Okay, there comes our object oriented principles, which helps us to achieve this kind of behavior. Okay, and a single entity can have its own data and behavior. Okay, they can have their own data and free will. Okay, in procedural oriented programming, okay, these entities, they simply had their own data. Okay, they didn't had any free will or behavior to act. Okay, they simply had their own data. Okay, they didn't have their free will, okay, to act on the data. Okay, so object oriented programming helps us to fix that. Okay, so the demerits of procedural languages here, entities only have their own data, they don't have any actions. Okay, they don't have their own behaviors. Okay, and multiple procedures, okay, multiple procedures can act or manipulate the entities in their own way. Okay, if they are not structured properly, then that can create issues. Okay, and and third point, we can say that it doesn't follow a very natural pattern. Okay, okay, so to address all these demerits, okay, object oriented principles was developed. So the advantage, okay, so the advantage of object oriented principles are, it's centered around entities. It's centered around entities. So here entities have their own data and related actions. Okay, here entities have their own data and related actions. Okay, in procedures the entities have their own data only. So in object oriented programming, entities have their own data and actions. Okay, 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 and this data and actions are very tightly coupled together. Okay, so what are the rules or principles of the object oriented programming? So if you say about principle of OOPS, there is one principle, that is abstraction. Okay, and you can say this is only one principle and it has three pillars. Okay, what are the three pillars? Inheritance, okay, polymorphism, okay, and encapsulation. So this this complete explanation was about the basics of low level design and object oriented principles. So in our later videos we will be understanding how we'll implement this. Okay, this one principle and three pillars, and later we'll be learning design patterns, more design patterns. Okay, thank you all for watching these videos. Please excuse my bad handwriting. Okay, please like and subscribe my channel for more such educational content. Okay, thank you.